This one should, I hope, be pretty short, but today you're going to need a periodic table that is blank. There is one in the Schoology folder because we're going to color the periodic table to overlay where the metals, the nonmetals, and the metalloids are. While you're printing this, you're going to need one more in this unit, so if you wanted to print another one, if you need to come up and get one, I can send some to the front office for you to pick up as well. That's up to you. I always have copies available. Same thing with your notes. If you want me to copy it and leave it at the front office, you can definitely do that. But we're going to look at the periodic table today with kind of two distinctions. And we're going to look at what's called the modern periodic table. It's basically Moseley's periodic table, but we call it Mendeleev's. And the Moseley's periodic table is all arranged out into rows and in columns. And with those rows and columns, we already know, so you're going to want to watch this video, so go back to the PowerPoint or the Google Slides and watch that. But we already know that a horizontal row, so horizontal goes with the horizon, a horizontal row on the periodic table is called a period. So with your periods on the periodic table, there are actually 7 of them, and they go across this way. So period number 1 includes hydrogen and helium. Period number 2 is lithium down to neon. All the way down to period number 7. Now these, what we called the F block in the last unit, these F block elements fit into the periodic table right here, so there's actually only 7 periods. So they get numbered off 1, 2, 3, 4, 5, 6, 7, and we're going to number those off on your periodic table here in just a moment. So periods, there are 7 of them, 7, and they go horizontal. The vertical columns, up and down, are called groups. There are 18 groups on the periodic table. So if I switch over to my document camera here, on your periodic table, because you're going to need to reference this in some of the things that we're doing, we're going to number this off. So your periods go across. So periods go across this way. There are 7 of them. So they just get numbered off 1, 2, 3, 4, 5, 6, and 7. This cerium and thorium, like going across here, these are a part of period number 6. These are a part of period number 7. So they fit into the periodic table as we're counting across 55, 56, 57, 58 jumps down here. You number down to lutetium at 71 and then back up to hafnium across at 72. So there's 7 periods going across. For your groups, these go up and down. There's only 18 of them. So for my 18 groups on the periodic table, they get numbered off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, and 18. So we have all the groups numbered off. If I ask for the group number of niobium, it's number 41, niobium is in group number 5. It's actually in period number 5. If I ask for the group and the period for silicon, silicon is in group number 14. It's in period number 3. So these up here both have groups and periods. But if we look at cerium down here, number 58, cerium is in period number 6. It does not have a group. So the ones at the very bottom down here do not have group numbers. If I ask for, I don't know, uranium, uranium is down here at the very bottom. Uranium is in period number 7. It does not have a group number. The only ones with group numbers are in the main part of the periodic table up here. So this, what we called the F block last unit, they don't have group numbers. I want to put this to the side for a second. We're going to go back to our PowerPoint, and we're going to look at the metals, nonmetals, and metalloids. Now with your metals, nonmetals, and metalloids on the periodic table, we're going to color that periodic table that we just wrote on. And first thing that we're going to look at is your metals. Metals on the periodic table, they all have a luster to them. That's a fancy chemistry word for shiny. They conduct heat and electricity. Conducting heat and electricity just means that it will travel across a metal. It's ductile. Remember, I don't know if you remember from 8th grade or not, but ductile means that you can draw it out into wires. And then malleable means that you can pound it flat into sheets. So you can make tin foil or gold foil or aluminum foil. That just means that you can pound it out real flat. In not so fancy chemistry words, ductile and malleable means that you can bend it and shape it and it will keep its shape. If you have a non-metal, it's not ductile, not malleable. You can't shape it, or if it does, it breaks apart very easily. Now your non-metals are the opposite. Metals conduct, non-metals do not conduct. They're dull, so they're not shiny. They're very brittle. That means they break apart very easily, and they're not ductile and not malleable. So you can't draw them into wires, you can't make them into sheets. Now, kind of stuck in the middle between the two, you have something called a metalloid. Metalloids have properties of both metals and non-metals. So maybe something is shiny, but it's brittle. Or maybe something will conduct, but not very well. Maybe it will conduct electricity, kind of, but not heat. So they have both properties of metals and nonmetals, and they're actually kind of trapped in the middle of the periodic table in a weird spot. So what we're going to do with these is we're actually going to color that periodic table. And in order to color the periodic table, you're going to have to find the metalloids. The metalloids are on the what's called the stair step on the periodic table. And if it touches the stair step on a full side, it's considered to be a metalloid. And that's for everything except for aluminum and polonium. I always say Alpo, like Alpo dog food. Aluminum and polonium are actually metals. They don't have any non-metal characteristics, so they're not actually metalloids. So again, I'm going to go back to my document camera here, and I have my periodic table that I was coloring, and I've got a marker. You're going to need really 4 colors, or 1 dark like pen or pencil, and then 3 like colors, crayons, color pencils, markers. I'm using markers because they show up here a little bit better. But we need to find the stair step line first. In order to draw the stair step line, you start here next to boron and you draw a line. And you just go 1 element over, 1 down, 1 over, 1 down, all the way till you get to the bottom of the periodic table. Now these blank spaces on the periodic table, I'm not taking credit for it, but chemists have actually identified what those elements are. They've made them in a lab. We're making such small samples, I'm going to be honest with you, there is a lot of debate whether these two that touch are metals or nonmetals. Don't worry about them for this class. We're going to kind of stop right here with polonium and astenine down here. But I went ahead and I just drew that line. So with that stair step line, if an element touches on a full side, so not a corner, but a full side, it's considered to be a metalloid for everything except for aluminum and polonium. Aluminum and polonium are metals. They are not metalloids. So what we're going to do now is we're going to take our next color. I'm going to use pink, and I'm going to color in my metalloids. And as I color in my metalloids, boron, silicon, germanium, arsenic, antimony, tellurome, and astenine, all of those have characteristics of both the metals and the nonmetals. So they're kind of trapped in the middle. We're actually going to end up eliminating them next unit, but truly they are metalloids. So a boron is a metalloid, silicon, germanium, arsenic, antimony, tellurome, and astenine. Now the next thing that we're going to do is we're going to color the non-metals. For my non-metals, I'm going to get another color. I'm going to use purple. It's just the next one that was in the box. And we're going to color everything that is to the right of the stair-step elements, the metalloids. So carbon, phosphorus, selenium, iodine, radon, like everything in this little corner are all considered to be nonmetals, along with, this one's kind of misplaced again, hydrogen. So last unit we talked a little bit about the fact that helium isn't really placed well in the periodic table, that it could kind of fit in right here above beryllium because it's part of the S block. This is a case that hydrogen doesn't fit in very well either, that hydrogen could be written down here above fluorine except for its number of valence electrons. So hydrogen is a nonmetal. So we're going to color hydrogen along with everything over here the same color. So my periodic table now, I didn't color it in, I was kind of lazy. But my periodic table now has hydrogen, and then everything to the right of the stair step all colored the same color, and I labeled those as nonmetals. Now everything else that's left on the periodic table are all metals. So everything that's left on the periodic table here are all shiny. They're conductors of heat and electricity. They are ductile and malleable. So the majority of the elements on the periodic table are all considered to be metals. So I used a different color, I used a green color, and I colored in all of my metals. So all of these elements have similar characteristics. Metalloids are stuck in the middle, and then my nonmetals that we colored last time are all dull. They're not conductors of heat and electricity. They are not ductile, they're not malleable. So now your periodic table should look like this, where you have 3 different colors. We have our stair-step line in the middle that we made first. I have my metals one color and labeled, and I have my nonmetals a different color and labeled as well. Now we're going to use this next class period, and we're going to look at the families on the periodic table, and we're going to get their characteristics. So as we talk about their characteristics, we're going to have something called like the alkali metal family. The alkali metal family that's right down here in green, lithium down to francium, they're going to have the characteristics of the metals and additional characteristics as well. So looking at this, we're going to need this next unit, so that's why we went ahead and colored it out today.